So we are a collection of engineers and biologists and chemists, and our objective is to improve on the current dispersants and make new advances in dispersant science that might be of help if there's a subsequent oil spills. And we try to design dispersants that use significantly less solvent, significantly less of the surfactant component that persists for extended periods. We use a simple, biologically safe materials. You want to target these dispersants to the interface between oil and water. So you want dispersants that will have a high encounter rate with the oil, that they will stay along, that they won't just dissolve away in the bulk of seawater and not get exposed to oil if they are not delivered directly onto the oil. We actually use minerals like clays, but the clays have a very unique morphology. They are tubular, and so they have a hollow structure, and you can put the dispersant components into these lumens of these tubes, and the clay looks like a rolled up, like a scroll of paper that's rolled up. They are natural, they are available in large quantities, and so the idea is that these minerals will stick to the oil-water interface, and then they will deliver these surfactants, which now go very quickly to the oil-water interface, and they take the oil and break it up into smaller and smaller droplets that then can be dispersed. So we're using the natural concepts of oil mineral aggregates, but we're designing it with the specific minerals that will deliver dispersants. Since we have a strong component in the biochemistry, we want to also see how well these things can disperse oil, whether the minerals allow colonization of oil degrading bacteria, and they can use the mineral surfaces as a scaffold to build biofilms, and so on. We want to see whether having these clays at the oil-water interface will foster biodegradation. We can see things now and this is called cryo-electron microscopy. We can see things at very, very high resolution, so we can actually look. It's much better than optical microscopy. We can see things like details of biofilms, the details of the oil-water interface, how things are, what's happening there, and we hope to use these sophisticated tools. We also use tools such as neutron scattering to understand droplet structure, what the interactions of these surfactants are with cell walls of bacteria. So we're hoping that at the end of this thing, we have developed a improved dispersant that has much less solvent, has very biocompatible compounds that foster biodegradation, and we can hope to understand a lot of the fundamental processes that happen at the interface between oil and water.